Welcome to Support HVACR Trade Training. In this lesson, we'll walk through the tools you'll need and a step-by-step process to troubleshoot a reversing valve safely and accurately. Remember, learn faster, troubleshoot smarter. Let's start with the essential tools for this job. A digital volt multimeter to check for voltage and resistance. Clamp thermometers or pipe probes. 2 is ideal for accurate temperature comparison. A set of manifold or digital gauges to read system pressures. A magnetized screwdriver for a quick coil is magnetized test. And of course, proper PPE, gloves, and eye protection. Always gear up before touching any part of the system. Before doing anything else, safety first. Make sure you're working with the correct refrigerant. Connect your gauges and temperature clamps securely, and always keep your hands away from hot discharge lines. After changing modes from heating to cooling or vice versa, allow the system to run for about 3 to 5 minutes before taking readings. That gives pressures and temperatures time to stabilize. So now let's get into the steps. Step 1, command check. From the thermostat, call for cooling, then heating. At the outdoor unit, measure for 24 volts AC between C and O or B on the control board. If you're not reading 24 volts, the issue is not the valve. It's likely in the thermostat, control board, or wiring. Always confirm the signal before blaming the valve. Step 2, check the solenoid coil. With power off, disconnect the 2 coil leads and measure resistance. If it reads open line OL, the coil is bad. If it reads extremely low, below about 5 ohms, it's shorted. Most healthy coils read in the range of a few dozen ohms, but check the manufacturer's specs. Now power the system back on and verify the 24 volts AC at the coil when the O or B terminal is energized. For a quick field test, use your magnetized screwdriver. If it sticks firmly to the coil, it's energized. If the coil fails but the valve body itself is fine, you can replace just the coil. No need to open the refrigeration circuit. Step 3, check if the valve actually shifted. Listen carefully when switching modes. A healthy reversing valve will make a short whoosh sound as the internal spool moves. Then, after about 1 or 2 minutes, feel or measure your line temperatures. The discharge lines should be noticeably hotter than the suction lines, and the hot and cold sides should swap when the mode changes. If they don't, the valve probably didn't shift. Step 4, perform a temperature pattern test. Clamp thermometers on all 4 accessible tubes connected to the valve. In cooling mode, the discharge line going to the outdoor coil should be hot. The suction line returning from the indoor coil should be cool. In heating mode, the discharge line going to the indoor coil should be hot. The suction returning from the outdoor coil should be cool. If all 4 lines show similar temperatures, or if you see only small differences, the valve may be bypassing internally or leaking around the spool. Step 5, check pressures to confirm your diagnosis. A normal system will always show a clear split between high and low side pressures. If both pressures drift toward each other and system capacity drops, that's a sign of a bypassing or leaking valve. If the system stays locked in one mode no matter what the thermostat calls for, the valve is stuck and not shifting. And finally, step 6, rule out lookalikes. A miswired or incorrect OB setup can make a unit heat when it's supposed to cool or cool when it's supposed to heat. Also, don't overlook other causes like low refrigerant charge, outdoor fan failure, or liquid line restrictions. They can create similar temperature symptoms. Always verify superheat, subcooling, and fan operation before you call that valve bad. And that's how to systematically troubleshoot a reversing valve like a pro. Remember, precision comes from process, so follow the same steps every time. Don't miss the next lesson. Hit subscribe and turn on notifications for more HVACR training videos from Support HVACR Trade Inc. Support HVACR Trade. Learn faster. Troubleshoot smarter.